Hello everyone, welcome to the YouTube channel of NG Core. In this video, we will have a look at the open source project HEXAeBPF by Core RAN Labs. So HEXAeBPF is an open source eBPF-defined cloud native telecom solution. We are already at the repository. Moving down, we can have a look at the table of contents where they have introduced the project, provided features, the design principles, end-to-end setup, logs, and the roadmap for the project. So again, it's a telecom solution which is eBPF defined. It provides you with low latency and enhanced scalability and a lot more features. So let's have a look at the design principle, and here is the architecture diagram. So over here you can see we have the NIC, and when the packet arrives at the NIC, it is then forwarded over here to the NIC driver, and at the XDP hook point we have implemented our BPF programs. The pass header, based on whether the packet is of UDP or GTP type, forwards it further, and then it will pass it to the detector where it will look for PDR, and then depending on the precedence it will check for QER, or else it will directly update the control plane. Similarly, in case of high precedence, it's sent over to the enforcer and the forwarder back to the control plane. So the sharing between the user space and the kernel space is done via eBPF maps. So the 5G core is running in the control plane. So like here we can see the control plane is provided by Aether's SD core, which is a Linux Foundation project. In the user space layer, the UPF is an in-house solution developed by Core RAN Labs. And then further we can see the descriptions of the user space and the kernel space layer over here. So let's have a look at the second diagram. Over here at the parser, when the packet arrives again, it is divided based on the basis of GTP or UDP. It is then sent to the detector, and in detector it is checked for precedence. In case of high precedent, it is moved further down over here where we have the forwarder and the enforcer. And in case of low precedence, the packet is directly sent over to update it in the control plane session. Here is an explanation basically of what we just had a look at, and let's now move down, and they are providing descriptions about parser, detector. So let's have a look at their end-to-end setup. So this is the end-to-end HEXAeBPF topology. Here we can see the COTS UE, the radio unit, and it is connected to a RAN stack solution, ARIA, and then further we have HEXAeBPF over here, which acts as the core. Now moving down, it has been successfully tested with 3 RANs, ARIA, OAI, and SRS RAN. We have 2 commercial RUs, 2 simulators, and a lot of COTS UE. So now in the control plane configurations, you can see they have configurations for us. They have provided the UPF configurations over here. We will of course use these configurations once we try to deploy it. They have provided these steps to deploy HEXAeBPF. Then we can check connectivity with simulators. They're also working on some simulators. At the same time, they have provided us with logs to check for this. These are the UPF logs over here. So now let's deploy it on a machine. So first of all, you have to clone the repo. I have already cloned it. Now I will run their steps, and first I'll start with the fresh system. I will use this command to clean up. Okay, now we're ready to deploy. So now let's copy the core directory to the home directory. So you have to copy the core directory to the home directory. I already have the core directory copied in my home directory, so we can have a look at that. Beside this, we have the Helm charts for SD core deployment. Now let's move back to the HEXAeBPF directory. So now we will deploy the control plane first. So you can configure the interface for yourself. And once this command is used to deploy, it will take some time before the control plane is ready. So we will fast forward this procedure for you. Right, so once the control plane deployment has been done, you have to check the pods if they are up and running before you deploy the UPF. So here's the command to deploy the UPF. First, we have to check if the control plane pods are up and running. So you can see all of them are healthy. Now we can deploy our UPF. So the deployment has been successful. So now let's have a look at the deployment and check if all of our network functions are working fine. So we will check for pods in the Hexa namespace, and here you can see all of the network functions are here, which are up and running and healthy. Now let's have a look at the logs of AMF first. So here you can see the logs of AMF, information about the network slice. We have information about MC over here. You can see status about GNB, and down here all the values MCC, MNC. And again, now let's have a look at the logs of the Hexa UPF. So you can see the attach mode is generic. We have PFCP address, the entry address. The attachment of the XDP program on the interface was successful. Then we have the association setup request. Right now on the left, I have the logs of AMF, and similarly on the right, I have the logs of UPF. Now we will try to connect it with our with the RAN solution. Now we will try to connect it with the RAN solution ARIA. Before we run it, we can see the radio unit on top, and as soon as the GNB is connected, the light will turn green, and I will be updated in my logs. So you can see the GNB is detected. So now we can have a look at the logs once we have detected the GNB. So moving down here, you can see the PLMN ID, the tag, and on the right side, you can see that the UE is also detected. We have the establishment request, and down here we have the session modification request also. And on the left-hand side on the logs of AMF, you can see that the PDU session has been created. Now let's have a look at the multiple BPF programs that we have attached at the XTP hook in the kernel, which is done for better performance. Here you can find the names like QER, etc. These are basically the associated maps to the respective PAR, QER, and the eBPF programs. So you can see the name UPF route start. These are the maps, associated maps. Now we will be testing the deployment with the UE, and I'll remove it from the airplane mode. And if you go inside this, you can see that the DNN which we have selected over here is Hexa. So now we will test it if the internet is working or not. So here you can see the internet seems to be working fine. So once this is done, now we move on to the iPerf test. We will use UDP uplink first, and you can see here we get a speed of about 1 Gbps. Similarly for the UDP downlink, what we can see that over here is that we again get a speed that is again close to 1 Gbps, approximately 900 megabits to be exact. So in the roadmap, you can see they have upcoming integration with a lot of open source projects like Hubble, PWRU, L3F, LogCLB. Similarly, they are trying to run this open source 5G core and make it compatible with other 5G cores like OAI, Open 5G S, Free 5G C, Magma. So that was all for this video. Thank you so much.